Okay, thank you, Mladen, for that introduction, and welcome everyone to today's webcast. So I'm going to kind of go through this presentation in three parts. Right? The first part, as Mladen said, is going to be about why we chose CouchDB and subsequently why we chose Erlang to power this cloud database service, and not only discuss some of the architectural implications, but also the kind of implications for the DevOps lifecycle. Right? The second part of the presentation is going to be a preview about CouchDB 2.0, some of the new features, some features which may be familiar to users of Cloudant, but unfamiliar to users of CouchDB itself, and kind of run through some of the ones that I think are more impressive. This release has been a long time coming, and there's lots of really great new capabilities showing up and available in the master branch today, and I want to kind of share a few of those with you. And then the final piece I want to talk about is just a few reflections on what we've learned as a community as this project has evolved, over the past 7, 8, 9 years, and things that we have grown to be sort of staunch believers in as essential to the kind of establishment and growth of successful, healthy, happy open source communities. So with that, let's kind of take a step way back. To the beginning of the founding of Cloudant. I want to kind of talk about the story in terms of a personal journey. So when my co-founders and I were working in a research experiment in physics, and we wanted to start this company, the first thing we said we wanted was to build a horizontally scalable distributed database system. This was 2008, and such database systems were sort of the purview of the big web companies, but there weren't any open source offerings out there that played in this space successfully, right? And of course, we weren't the only ones with this idea. In the year after we founded the company, the NoSQL term was born. We helped organize one of the first conferences for it, and of course now there are dozens and dozens and dozens of databases that have cropped up and really spawned a Cambrian explosion of systems that have done some fairly innovative things, and have begun to learn from one another and really sort of mature the ecosystem into a set of products that are useful for running production applications with demanding scalability requirements, demanding availability requirements. But in the beginning, these things weren't out there, and we said we should build one. We think there's an opportunity for that. We wanted to kind of look around and see what prior art was out there and see if there was anything that we could evolve, and we bumped into CouchDB. And at this point in time, I think CouchDB was an Apache incubator project, and it was saying all the right things, right? CouchDB was claiming to be built for scale, right? To be making conscious design decisions that would facilitate, the running of highly scalable systems. The interfaces looked great, right? As researchers, we didn't have a strong background in traditional relational database systems, and this kind of dynamic, developer-friendly interface, a database exposed as a web service with, an HTTP interface and JSON payloads. Is something that was very easy to kind of get up and running with compared to the other alternatives that were out there. And the final piece that really impressed us about CouchDB was this kind of nifty take on replication. Most database management systems do replication using some sort of log statement replays, right? You write any updates to the database into a commit log, and then that commit log gets replayed on another replica in the database cluster. CouchDB and other systems like it take a different approach, where they actually rely on the ability to synchronize changes to each individual piece of data across these systems, right? And rather than replaying logs, they're actually comparing data element by data element, the contents of two different databases, and executing the operations that are necessary to ultimately synchronize these systems. And it's a fantastically flexible system, and one that opens up a lot of new possibilities for what it means to have databases that replicate with one another, including databases that live on mobile devices and interesting things like that, where the device might be disconnected for arbitrary periods of time. So the more we looked at CouchDB, the more we said, okay, this seems cool. We hadn't thought our way through all of the implications of the replication stuff, but we said, the scalability piece looks like the right thing. The interface looks like what we would have espoused, right? And then we sort of got more familiar with the code, and we bumped into Erlang. My co-founders and I were coming to this venture from a world of C++ for the heavy-duty numerical processing and analytic routines that we used in our experiments, and Python for a lot of the scripting and kind of management facilities and that was just kind of kicking off, right? So we looked at Erlang. The first thing was, whoa, you get concurrency out of the box, right? No more kind of blowing your foot off with C++ or kind of working around the global interpreter lock. This seems great. And then we said, well, we wanted to build a distributed database. How does Erlang help us there? And it's like, oh, this looks like free distribution, right? I can send a message to a process on another node in my database cluster just with the same syntax that I send a message to processes on the local machine. This sounds fantastic. So we were really smitten with those characteristics of the language, right? And said, okay, great. The Erlang seems like it's on a good path here. It seems like the right kind of language for building cloud servers, cloud services, and we should go teach ourselves Erlang in order to evolve this system the way we want it to for our business. So how do we do? What, six and a half years later, we're still here. So I think that's one measure of success, right? CouchDB is still strong and growing. Cloudant is still delivering its service to thousands of customers every day. So something went right. And I think we've absolutely found that the use of CouchDB and Erlang underneath have been strategic advantages for us as we've delivered this service. But I think the reasons that they've turned out to be so important have maybe been slightly different than what we initially expected, right? So one of the things that we didn't think about at first, but turned out to be really, really important is, CouchDB is a database that really cared about getting the durability story right. It sounds silly, but lots of database systems make trade-offs in this space in order to kind of move quickly, right? Or don't sort of fully think about the ramifications of what it means to durably store data on disk in all sort of variants of Linux systems and cloud servers. I know our infrastructure team at Cloudant has got an open ticket with a provider right now that shows an XFS file system sort of randomly unmounting, right? And having a database system that has thought ahead about how to handle those kinds of crazy situations is really, really helpful. It's kind of saved us time and time again the sort of very well thought out, ultimately very simple and elegant approach that CouchDB and other kind of purely append-only systems take to storing data has proven to be a real sort of help for us. So the durability piece was great. Replication, true enough, that remains the killer feature. Right? And I think we've found that time and again that this is something that is really differentiating about this project and something that we've built more and more of an ecosystem around as time went on. On the Erlang side of things, one of the things that we learned, right, is that there actually is no such thing as a free lunch when it comes to data distribution. The syntax and semantics are great, but I think as most developers of distributed Erlang applications can tell you, or should be able to tell you, that you do have to still think very carefully about what the control plane looks like, what the data plane looks like, what is the distribution of messages that you're sending across the different channels. These things, you don't get to sidestep the kind of practical realities of distributed systems just because you have a language that embraced the concept of a distributed application in its own framework. But that being said, we continue to leverage the Erlang distribution heavily in all of the database clusters that we build, and we've done a number of optimizations to ensure that we're able to provide a high throughput, low latency database service that makes the most of this distribution protocol when it makes sense. On the other hand, one of the things that we didn't even consider at all when we were starting out and turned out to be a huge, huge help is just the ability to dive into these virtual machines as they're running. I'm hardly the first person to mention this characteristic of the virtual machine, but I do want to reiterate the comments that have been made by others in the community. Going back to a system that doesn't have this kind of live introspectability it's kind of a scary thought in some respects for us now. Certainly you have to be a heck of a lot more careful about figuring out what sorts of instrumentation to add, what sorts of logging to add, and those things continue to be very, very important for people building Erlang applications. But there's nothing like finding a Heisenbug of sorts, right? The kind of thing that doesn't lend itself to easy logging and debug and instrumentation information and post hoc analysis of a situation. Something like finding one of those and being able to hook up to a running system where the bug is manifesting and diving in and inspecting the live state of running processes and how those processes are interacting, right? That's an incredibly powerful capability, and one that is mostly unequal throughout the space. And certainly as more and more applications move to software as a service, move to cloud applications where the operations team and the development team are kind of co-located, I feel that this is a fruitful ground for Erlang in general. It's been certainly a very, very powerful asset for us in Cloudant. So I think that's the kind of quick rundown, and we can certainly dive into more details about how, what operational tooling we've built into Cloudant and how kind of Erlang fits into our overall development lifecycle and those sorts of things. But I do want to make sure that we reserve enough time to talk about some of the interesting things that are happening in the CouchDB community. And so I want to kind of switch to the second portion of this talk now, which is really what's new in CouchDB 2.0. Right? And there's 4 things that I want to focus on. The first is the database clustering piece. This is something that we developed internally at Cloudant and open sourced a few years ago, but because it was a fairly substantial change and actually a fork of the code base at the time, we had to do a lot of work to kind of get it into a place where the 2.0 release was really ready to go. I'm happy to say that that's moving along really, really well now. All of this code exists in master and so on and so forth. So what does that really look like, right? And the way that we've chosen to do this is to utilize consistent hashing for the database. So the idea here is we're taking a single logical database, CouchDB database, and distributing it redundantly across a cluster of servers, right? So a database clustering is governed by 2 parameters, the partition count or the shard count, we use these terms synonymously, and the number of replicas of each shard, right? This is relatively standard stuff. We use consistent hashing to route the documents to the shards, and for those of you for whom that's not a familiar concept, it's actually fairly simple. You simply take the primary key of the document, you hash it. That gives you a value in the key space of the hash function, or the output space of the hash function. You can represent that as a continuous ring, and then just simply carve out equal partitions of that ring, right? So this maps, a potentially very large space of primary keys, numbering in the billions for some of our larger databases, into a very much more finite number of partitions, right? So the amount of cluster state that needs to be maintained is really just what are the partitions of each of the database, and where are the replicas of those partitions hosted across the cluster, right? So managing that amount of cluster state is relatively straightforward. That cluster state has to be gossiped throughout the cluster so that each node in a CouchDB cluster is able to independently know how to route requests for a particular document. And we have a straightforward solution to that, which is just to simply use CouchDB's replication protocol. So that's like a little node local database that gets gossiped in between the servers in the Erlang cluster, right? The other thing that that we're able to do in this case is, because we're using a nice database to support this management of the partition table, we can afford to do the partitioning for each individual database separately, right? Which is awfully useful if you have databases that are growing at different rates, databases that have different needs in terms of their resources that are being consumed in the cluster, and also useful for situations where new databases are continuously being created and you'd like to continuously grow the cluster. You can sort of define placement strategies so that new databases land on less loaded nodes and just sort of fill those up as you go along. So there's a lot of flexibility basically in the use of databases to model this partition table for each larger clustered system. So that's how we route the documents to disk. So let's talk a little bit about the way that queries work. CouchDB's got, of course, the basic CRUD operations on individual documents, and we also have a number of systems for building indexes on, attributes of these JSON documents other than the primary key. Okay? So the document operations in a clustered 2.0 CouchDB, those document operations are subject to quorum protocols. And in a quorum protocol, the system is actually going to ask each of the hosts that's responsible for storing a particular document in the cluster to acknowledge the operation, and it will by default wait until a majority of those replicas have acknowledged the operation before acknowledging back to the client the operation was completed. Right? So when you go to write a document, that write request lands on any node in the CouchDB cluster. That node knows how to compute the right hosts for the document using the consistent hashing logic that we talked about in the earlier slide. And it sends the request, it forwards the request on using distributed Erlang to those individual hosts. Those hosts write the document to disk in the appropriate shard file and then send an acknowledgement back. And similarly, on a document read request, the coordinator node, we call it, which could be any node in the cluster, right? They're not special. Each node can function as a coordinator for any request. The coordinator looks up the right information and asks the replicas to retrieve the document, right? And there's a bit of subtlety in these systems that has to do with reconciling any divergences. It's an eventually consistent system, and it's certainly theoretically possible and something that we see in practice that the individual replicas don't always have the exact same version of the document. And in this case, we rely on the same version tracking information that CouchDB has always used to understand the edit history of documents that are replicated between systems. We use that same revision tracking information to reconcile replicas of a document within a CouchDB cluster, right? And so that's where we're able to execute a read repair function for those of you who might be familiar with these kind of dynamo-based clustering systems, where the coordinator can detect that there's an inconsistency in the versions of the documents that are stored in the cluster, and if it detects that inconsistency, it also knows how to repair it, because the lineage information is tracked and stored with each document. So it can execute that repair function and then return the result of that repair to the client. In addition, there's an active anti-entropy mechanism that's always running in the cluster, which is sort of proactively reconciling any divergences that might have existed between shard replicas. So that covers all the document operations, right? For the views, or the query indexes that we'll get to in a little bit, the system is a little bit different, right? There's no quorums in this case, in part because views can have aggregations associated with them, and you're not any longer talking about results that are comprised of information from one document, but they're actually an aggregation of input from multiple documents. So what we do in this case is we actually have to ask every at least one replica of every shard of the database to give its contribution back, because the other thing that happens with these secondary indexes is that we don't have a priori information about which shards actually contain relevant entries for the query, right? The indexes are built local to each database shard, and now that they're indexing on things that are not the primary key, we don't get to benefit from that consistent hashing routing information. So we actually have to have the coordinator forward that request on to every partition, and then we respond once we've received results from one copy of each partition. Right? So it's a good system in that you get high throughput for indexing. If you need to scale out the indexing power associated with the CouchDB cluster, it's straightforward to build a database with a larger number of shards and distribute those throughout the cluster. However, there's a fixed overhead associated with each query, in that you have to hear from each, from at least one copy of each shard. So there's trade-offs, which I think is what distributed systems programming is all about. So that's the quick run through of the clustering system. The next feature that I'm really excited about in CouchDB 2.0 is all of the new work that we've done in the user interface system. Those of you who've seen CouchDB in the past, we've had a management interface called Futon that shipped with CouchDB and is delivered as a web application. And it's certainly served us well over the years, but it also has been getting a bit long in the tooth. Futon shipped with releases of CouchDB dating all the way back to 2008. And so what we've a bit of work that we've led at Cloudant and have really pushed forward in the open source community is a rewrite of that user interface, picking up some newer client-side JavaScript frameworks, a mix of Backbone and React, and building something that was architected in a cleaner way to allow people to come in and contribute more easily, and to add plugins and to add modules, and to give us a foundation on which we can really evolve the kind of portal to the database over time. So this is codenamed Photon. It's shipped as an experimental user interface in the latest 1.x releases of CouchDB, and is the management interface and user interface for the 2.0 release. And so I'm very excited about all the work that's gone on there, and really about the ability of that team as well to iterate and build things quickly, and also to sort of simultaneously serve the needs of the open source community as well as the Cloudant user interface, which is downstream from this. I think that's been a very successful kind of open source collaboration that we've had going on for a while. Let's Photon. Next, I want to talk about how you query documents in CouchDB. Right? CouchDB has always had the MapReduce view engine, right? And this is, MapReduce shouldn't be confused with sort of Hadoop-flavored MapReduce, right? This is really a system to allow you to upload some code to define indexes on JSON documents, right? Instead of using a create index statement, there was a function. The function accepted a JSON document as an input parameter and could emit 0 or more key value pairs from that function. Those key value pairs would be maintained in a sorted index. And you could use HTTP requests and query string parameters to slice regions of that index that you had built. And then you could optionally add a reduce function to build some aggregations. It's a flexible system, and it allows you to craft sort of options to satisfy query. But we also recognized that there was a learning curve associated with it. MapReduce sounds like a scary concept, and it's perhaps a bit unfamiliar, right? And so what we've done is recognized that other document databases like Mongo have provided ways to define indexes and execute queries that have proven to have a less steep learning curve. And so to give credit where credit is due, we've kind of worked with that team to adopt significant portions of the MongoDB query language and expose those in Apache CouchDB. So as of the 2.0 release, one of the things CouchDB can do is support a find endpoint that will accept selectors that look an awful lot like the selectors you would use if you were using MongoDB. It's possible to use most of the kind of special dollar operators that MongoDB supports. It's possible to do field selections. And the system will, it allows you to define one or more indexes on different fields. The system has, a query optimizer that tries to select the best possible index to satisfy the query that you submit. All right, so it's it's clearly a move to try to make the system easier to use. And the other thing that it does for CouchDB that I'm excited about is because it's a declarative language, because we have this optimizer in front, we can also start to unify different indexing systems that are available under the hood, right? You can think about a world where the full text indexes get surfaced through that same unified query system, and ultimately, make it possible for people to build compound queries that are served from a mix of full text indexes and traditional B-tree-based indexes in a single query. And so I think this is, again, a kind of really solid foundation for us to improve the way that people find documents in their CouchDB databases and improve the kind of overall ease of use factor of the system. And then the final thing I want to talk about is a bit of inside baseball on the internals, right? But I think it's a really nice one for anybody who's tried to use CouchDB with very large databases that see an awful lot of writes. So, I've mentioned a couple of times that CouchDB has this very bulletproof durability model, right? And the way that durability model is achieved is by refusing to ever update anything in place. Everything in a CouchDB database is a purely append-only index structure, right? You update a document, that new version of that document is written to the end of the file, and then all of the edits to the individual indexes that allow you to find that document are also appended to the end of the file. And then those updates are only made visible once a header that points to the new version of the index is written at the end and durably committed. Right? So it's a very nice, clean system. It results in a very crash-friendly behavior. There is no such thing as an unclean shutdown in a CouchDB database. But the trade-off is, wasted space, right? All of those old index pointers are no longer valid, and the amount of, sort of garbage that gets generated with each document update is, it's measurable. It's substantial. We've always had a compaction process. If you've used Postgres, you know that you need to periodically vacuum your databases. The concept is fairly similar here, right? but in 1.x we had, some deficiencies in the way the compactor worked. And those resulted in behavior that was a little bit hard for users to know about a priori, right? Turns out that databases, the degree to which we could compact them depended on the way that you chose your primary keys. It depended on whether you had sort of random IDs or not. And if you did have a so-called poor choice of ID scheme, then the best we could do was a compacted file that still had wasted space, and we spent a lot of resources to get you there too. So it wasn't great. And the solution to this is quite nice, right? It's, it sounds simple, but working, in the database internals in a system like this is never really, truly simple. So what we do now is when a database gets compacted, there's a temporary file that maintains sort of the live entries from the, the primary key index, extracts those all out of the main file, and then allows us to write those things in the, in the optimal order into the compacted file, right? So that ordering system has, a whole host of benefits, right? It means that the final file size is a lot smaller because the temporary file pretty much sort of swallows all of that wasted space that used to be delivered into the compacted file. It uses fewer resources overall because the temporary file gets written in, a much simpler format that doesn't have to care about the final index format, and we're able to achieve higher throughput too, in part because we're trading away a lot of random reads that used to be used to update databases that used, random choices of IDs, right? So it's a win-win-win as far as the compactor is concerned, and aside from being sort of much more performant overall, it also makes the system more predictable in terms of the resources that it consumes, regardless of the way your application chooses to assign IDs in the overall space, right? And so I think this is something that we've seen sort of quite often in heavy-duty production usage of CouchDB, certainly within Cloudant and also within reports that have come in through the open source community in general. And the new compactor, I think, is going to be a very welcome addition in that front. So, database clustering, new Photon user interface, the Mango query language, and this rewritten compaction, I think, are 4 key highlights that I'm really excited to kind of see go out the door with 2.0. So yeah, I think it's really it's an exciting time for CouchDB in general with that release coming out. And I think it's an opportunity to reflect a little bit on where we've been and what's worked, how to really drive a successful and exciting open source community. Right, we've come a long way since this original C++ and XML code base. The Apache Software Foundation has this saying, right, this motto, the community over code, right? And it's easy to kind of say that and walk away, but I think we've over the years come to appreciate the benefits of taking it seriously, and have become firm believers in the value of that concept. Last year we put together a code of conduct for the project, and John Jose really led the effort here, and it was a rousing success. The code of conduct was adopted by the Apache CouchDB project and subsequently adopted basically unmodified by the Apache Software Foundation as a whole. And one of the things it did was, it gave us a chance to introspect a little bit, to reflect on how we were running the project and what we were prioritizing and what behaviors we were encouraging in our community, and whether those were the behaviors that we wanted to be encouraging, right? And it also, as we looked through it and as we kind of wrote down what kind of community we wanted to have, right, it naturally caused us to kick off some initiatives that helped us get to that community. And I'll go into those in a little bit, more detail. But I think that was, there was a lot of interest in establishing these codes of conduct around that time. But I will say that overall, I think it was a very positive experience for our project to kind of go through that introspection. The second thing that we learned is that you can never do enough to eliminate barriers to adoption, right? It's easy when you're sort of deep into your own project to forget about those little quirks, those little errors in the documentation for getting started, right? The kind of 5 additional steps you had to do when setting up your development environment, the thing that you had to Google for on Stack Overflow to find the workaround for, right? Because it's a one-time thing, and after that you're off kind of working on your project, right? And the trouble is that every single person who, thinks about joining you in this project is going to bump into a very similar, situation, right? And it's easy to miss this kind of work when you're thinking about, okay, what are the blockers for us to get this release out the door? What are the things that are prioritized in the backlog, right? But I think what we've found is that every time where we've invested in eliminating barriers to contribution, eliminating barriers to adoption, we've been paid back in spades, right? Maybe one of the most sort of stark examples of that is the work that we did to bring the source code management system up to Git, right? For those of you who've been around Apache for a long time, all of the Apache Software Foundation projects were hosted in Subversion for many, many years. Makes sense, right? Subversion's an Apache project itself. But we also recognized that these, by using a distributed version control system, we enabled a sort of easier collaboration with members of the community who weren't committers, right? And so we sat down and really kind of worked closely with the Apache Software Foundation infrastructure team to first prototype and kind of beta test the integration, first a mirror of Subversion repositories into Git, and then ultimately allowing for write access. And that certainly was something that we could measure very, very clearly the rate and pace and increase of contributions that happened when we were able to first provide access to Git and then also mirror those repositories to GitHub, right? And the whole Apache, ASF has really come around on this to the point where now, we've got a very nice tight integration with the pull request model of the ASF. And you see many projects, especially newer projects at Apache, who, are happily kind of transcending the boundaries between, ASF hosted infra and other third-party applications, with the goal of just providing a welcoming community. If you want to submit a patch on GitHub, we can figure out how to incorporate that into the workflow. If you want to submit a patch at Jira, we can figure out how to work that into, right? Asking people to conform to the ideal process that you've developed because you think it's a more efficient model of working is sometimes necessary, but you really have to ask yourself if it is, right? And whether there are ways that you can kind of meet people where they choose to work and bring them in that way. Right. And then I think the last thing we learned, and this is one that was a sort of significant evolution for the project management committee over the years, is kind of when do you choose to bring on a new committer, right? So it's a significant step. You're saying I trust this person with access to the source code repository, and the wrong commit in the wrong place can sort of seriously damage, the project's reputation, can damage the businesses that are built on that technology, right? It's a significant step. But what we learned is that, in fact, people are generally trustworthy, and just because you've given access, commit access to someone doesn't mean that that person's going to go start refactoring, the core database internals in a way that doesn't make sense, right? So rather than treating it as kind of a big gatekeeper step, right? Thinking about the commit bits in an open source project as a public declaration of trust is, I think, really powerful. And what we've seen is that, by making that public declaration of trust, we have time and again sort of noticed that actually incentivizes significant, kind of deepened commitment to the project and an increased level of contribution. And so we, went on this kind of very conscious decision to foster, really grow the committer base quickly. And, by all accounts, I think it was a very sort of rousing success, right? And I think, that also kind of goes hand in hand with the notion that contributions come in all shapes and sizes, right? Too many open source projects are kind of think of committers as the folks who know how to evolve the core code base, when in fact, a successful project depends on a lot more than just differentiated intellectual property, right? There's, just as important as kind of what are the getting started, experience of working with the software, right? Is it easy to, obtain the software? Is it easy to build it? Is it easy to figure out how to do the kind of hello world example, right? And, a dedicated focus on that, first experience of the software, and a dedicated focus on getting kind of advocacy materials out there is, something that pays back in spades in our experience. And so, I think that that the project has made great strides in sort of increased focus on that, with things like weekly news emails that go out and blog posts that go out, and sort of curated discussions from Stack Overflow that people have found really insightful, and those little things, they add up in a big way. So it's been a long, strange trip, and one that I would happily do over again. And I'm really sort of proud of the community that we built, and the code that community is producing. So with that, I think this basically concludes the key part of the presentation here, and thank you again for your time, and I'm happy to answer any questions that might have come up in the chat.
So first of all, Adam, please allow me to thank you for a very inspiring talk, and one I can tell you has gathered a very large number of attendees, and I'm glad to say an equally significant number of questions have been flowing in. So as to try and honor as many questions as we can, we'll start asking them straight away. I would like to say that any questions we do not answer here and now at the webinar, we will follow up on, so you will get a response in writing from us to the questions that you've asked. But to start us off, here's a comment and a question from one of our audience, Adrian. And I sort of tend to agree, and I've often sort of thought of this myself. So Adrian is basically asking, why isn't CouchDB more popular? It's quite hard to find positive case studies or developer enthusiasm, whereas we're all aware of these qualities, and you've just sort of went into the detail. You don't hear as much about it, so to speak. Could you comment on this, please?
Sure. I mean, I think that one of the things that we prioritized early on was a significant investment in the core, right? A lot of the work that we went through was ensuring the viability and stability and overall kind of performance of that core code base, and we neglected a bit of the ecosystem that surrounded it, right? We neglected the kind of first experience, right? And I think what we've learned is that while it's hard to diminish the importance of having that core foundation on which to build, the ecosystem around it is at least as important. I know I've spoken with people from the MongoDB development team before, and they said, yeah, sure. I mean, the development teams that we have on our client libraries are just as large, if not larger, than the groups that we have on the core code base in many respects, right? And for a very long time, CouchDB hasn't had client libraries to kind of ensure idiomatic use of the database, right? It became a database that if you knew how to efficiently work with a web service, could pay back, great dividends, right? But if you didn't, there were stumbling blocks that we didn't do a good enough job of helping you avoid, right? And I think we've recognized that, and are taking significant steps to rectify it, right? Whether that's kind of documenting the best practices, documenting the right way to use the service, or whether that's actually documenting it in the form of client libraries, right? I think that ensuring, A, the good getting started experience, and B, that the easiest path to take is the correct one, I think is really, really important.
Thank you for that. And again, I'd like to thank everyone for asking a number of questions now. We're getting more questions than we can possibly answer now during the webinar. So again, our apologies, but we'll try to answer as many as we can. We will answer all questions in the order they've been received. So I'll just move straight on to the next question. Richard is asking, can we add or remove nodes from a running cluster?
Yes, you can. What doesn't happen automatically is a rebalancing of existing databases across the cluster, right? But we do have command line tools that are being included to, well, the database will generate a rebalancing plan, and then there's a set of command line tools that act on that rebalancing plan. So full online automated rebalancing of a cluster as it is expanded or contracted is not part of the 2.0 release. It's still a human-assisted process, and there are tools that assist you with that.
Thank you for that. Just to sort of move on straight to the next question and try and answer as many as we can. We have another question basically asking, is there a Erlang API to Cloudant? It doesn't seem to be listed on the cloudant.com web pages. So one of our audience is asking, is there an Erlang API specifically to Cloudant?
Not to Cloudant, no. Cloudant's delivered as an HTTP service, right? So you have to, I mean, that as part of a cloud service, we can't afford to open up the Erlang API, right? Because it's the system is multi-tenant at various tiers. And if we add an Erlang API, then that would allow a level of access to the users that wouldn't be safe, right? CouchDB is, the 2.0 release has a much cleaner Erlang API than 1.x had. And so, I'm curious to see if there are more, pure Erlang usages of it than we've had in the past.
Thank you for that. Adam, moving on straight to the next question. One of our audience, Piotr, is specifically asking, which problems should I expect when running CouchDB in production? A bit of a broad question, but I'll let you comment.
No, I think we're probably the world's experts on it at this point, right? So, for a very long time, the database space management was an issue depending on the write load that you encountered. The new compactor goes a long way towards making compaction much higher throughput. However, it's still important to kind of schedule the compactions of the right databases at the right time, right? So space management is important in a system that, is purely append-only like this. Contention on individual document updates is always something that I think needs to be carefully managed. CouchDB will always get to a correct situation, right? It never throws away data. It's not like it's using server timestamps to reconcile conflicts. But if you were to build an application that had heavily contended updates on a single document, you'd find that that document would prove to be a performance bottleneck and that the conflict management itself would be sort of an annoying part of handling the application.
Fantastic, thank you for that. We have a very limited time remaining, but I'll try and ask as many questions as we can. So Christopher is asking, how exactly does CouchDB 2.0 benchmark against Couchbase and MongoDB, etc.?
I don't have solid numbers to deliver to you in this. I know we've kicked off some efforts to, get numbers that I think we can trust, right? Compared to, Couchbase, I mean, Couchbase has done a lot of work to ensure that read operations flow purely out of memory, right, using the memcached protocol. CouchDB continues to have an HTTP interface and go back to disk, so I would not expect, that the kind of low latency operations that you get from basically having memcached there, that's not going to be something that CouchDB is going to, strive to achieve, right? I think the comparisons with MongoDB will be more interesting.
Right. Thank you for that. That's much appreciated. Again, to try and sort of answer as many questions as we possibly can, here's an interesting one. So Christopher is asking, when exactly would you steer clear from CouchDB and sort of not recommend using it? What are the kind of use cases that you would absolutely, run away from, so to speak?
Sure. I think that there are certainly systems that analytically focused ones, right? I think is one where doing analytics inside of CouchDB is, generally speaking, not going to be your best bet, right? We built CouchDB to be an operational database, to be something that, stayed highly available in the event of all kinds of crazy server failures and was able to deliver responses to predictable queries with low latency. If you're in an analytics environment where you're asking a lot of ad hoc questions of the data and, queries are changing from execution to execution, I think the better bet is to use the change capture feed that ships with every Couch database and dump that data into a Hadoop system, into a Spark system, transform it into a relational shape and put it in a data warehouse, right? Doing the analytics right inside Couch, I think, is not something that we're targeting now or in the future.
Okay, thank you for that. Now here's a couple of questions I'm really curious about myself. So firstly, in regards to the release of CouchDB version 2.0, when would you expect that to be happening?
Yeah. I mean, it's ready when it's ready, but you know, the headline of the IRC channel is burning down the list of blockers for the 2.0 release. The master branch is, you know, in my experience, quite stable and useful, and you know, I feel like the database is sort of very clearly converging on a path that I would expect to result in a 2.0 release this quarter.
Fantastic, thank you for that. And finally, you know, we can entertain, I think, one more question. Perhaps a bit of a broad one for the end. How do you see the evolution of CouchDB following version 2.0? Where do you see CouchDB specifically going after that?
Yeah, so I think one of the things that, at least from the Cloudant perspective, we're really keen on is ensuring that CouchDB participates in a larger ecosystem of other data services, right? There are, you know, lots of ways that using CouchDB in a complementary fashion with other data stores makes a ton of sense, right? And so whether it's kind of getting, you know, the binaries that you can attach to documents out into an object storage system, or whether it's connecting, you know, providing that connectivity to analytics systems so that you can analyze the data you have in CouchDB in a very kind of low overhead fashion. I think those kinds of integrations are something that you're going to find, at least, you know, my team at Cloudant pursuing actively.
Thank you for that. Because we're getting so many questions, I can't resist just asking one final query. So Julius is asking, which Erlang version exactly will be used for 2.0?
So I don't believe that we're, you know, stipulating a particular choice of Erlang version. We have been doing an awful lot of investigations with Erlang 17.5, and you know, are looking at sort of a broader rollout of that throughout the cloud service. So you know, we're not sort of, I don't know that we're going to be on the bleeding edge of 18, but I would expect 17 to be the kind of, you know, preferred thing that we go for at this point.
Excellent. Well, Adam, a big thank you again on behalf of us and on behalf of, I'm sure, everyone who's attended the webinar. So first of all, thank you for speaking, and obviously thank you to our audience for attending. Please do join us again for our next monthly webinar. Just to say that following today, we will be sending you a short survey to make sure we capture your feedback of today's webinar. Please also note that the recording of the webinar and the presentation that Adam shared today will also become available for you to collect on our corporate website, which is www.erlang-solutions.com. Once again, thank you everyone, thank you Adam, and we look forward to seeing you all on our next webinar.